Welcome to this Masterclass Explainer Hackathon. Today, we're initializing our target mainframe, the Cambridge AS and A-Level Arabic 9680 Paper 4. Listen, we aren't just going to sit here and dryly read through the syllabus. No way. We're taking this high-tariff language exam rubric, and we are treating it like an algorithm that we can solve, debug, and optimize with absolute precision. So let's get to work and master the examiner's code.
Okay, check this out. Did you know that mastering the criteria in this specific 14 to 15 firm mark scheme accounts for roughly 15% of your total marks in Paper 2 and Paper 4? Seriously, 15%. That is a massive chunk of your overall score. You absolutely cannot afford to let memory leaks or basic syntax errors drag down your execution here. We need a flawless run.
So here's our system boot menu for today's run. First, we'll initialize the core concepts. Second, we debug the command matrix. Third, we enter the beta testing arena. And finally, code deployment.
All right, system boot, core concepts. Let's define the parameters of the exam and understand the exact hardware we're working with before we start writing any code.
The system essentially demands competence across three cognitive domains: knowledge and understanding, analysis, and evaluation. But here is the absolutely critical directive you have to remember. The Cambridge Assessment Framework prioritizes analytical depth over superficial breadth. Think of it like writing a really efficient script. The examiners, they don't want 1,000 lines of raw, unstructured data. They want a tight, logical function that proves you understand exactly how the variables interact.
To show you exactly what I mean, let's look at two theoretical student archetypes drawn straight from examiner reports. Meet DevAlex and DevSam. Now, DevAlex is fantastic at raw data inputs. Like, Alex basically memorized the entire Arabic textbook. But Alex causes constant memory leaks during the exam because of poor analysis. The data's all there, but it doesn't actually do anything. Then, on the other hand, we have DevSam. Sam has great logical loops and critical thinking, but completely fails the strict syntax and presentation rules of the mark scheme. Proper headings, correct terminology, clear annotations, Sam ignores them all, and the final score just crashes. To master this paper, you've got to combine Alex's data with Sam's logic and wrap the whole thing in perfect syntax.
Moving on to Section 2, debugging the command matrix. Let's look at how Alex and Sam can process exam data systematically without crashing the program. Notice the strict procedural framework here. Data interpretation isn't a guessing game, guys. It requires a hard-coded sequence. Step 1, you have to extract accurate variables from the provided texts and tables. Step 2, you interpret the relationships between those variables. And Step 3, you compile that into evidence-based conclusions. If you skip Step 2 and jump straight from extraction to conclusion, well, you just triggered a logic error and lost your method marks.
And this brilliantly illustrates the deconstruct, solve, evaluate algorithm that you have to use to tackle complex problem solving. First, identify your given info. Second, break the problem into logical steps. Modularize your code. Third, solve it systematically with your clear workings shown. Fourth, check for reasonableness. Basically, run a quick diagnostic to see if your answer actually makes sense in the real world. And finally, justify your recommendations based on that output. This sequence right here is exactly what the mark scheme rewards.
Okay, halt the compile screen for just a second. Before we push the final patch to secure those maximum marks, you need to optimize your own system feed. Subscribe to Ace the Exams right now and turn on all notifications for weekly system updates. Your exam algorithm is literally only as good as its latest update, so stay plugged in. All right, back to the code.
Welcome to Section 3, the beta testing arena. It is time for an immersive audit using the principal examiner reports to hunt down critical system errors.
Warning, we have a classic examiner alert straight from the server logs. Systems crash when answers are too vague. The examiners are explicitly warning us that generic pre-memorized textbook answers will simply not compile. They want specific details linked directly to the context provided in the prompt. If your answer could apply to any random text or scenario, you are failing the context check. It's that simple.
When we compile the logs, we find the top 3 syntax errors that cost students marks year after year. Bug number 1, vague or generic answers. Bug number 2, poor format and presentation, which basically means ignoring headings, missing annotations, or using the wrong terminology. And bug number 3, lack of specific context. Honestly, these are completely preventable bugs if you just run the right patch.
And to debug those logic errors mid-argument, we deploy the Peel syntax patch. Think of this as a strategy to upgrade your paragraph instantly to Cambridge standards. P is for point. That's your variable declaration. What are you actually arguing? E is for evidence, your direct data pull from the Arabic text. The second E is for explanation, your analytical function, like how does this evidence prove your point? And L is for link, your return statement tying the whole paragraph back to the specific context of the prompt. Apply this framework, and you'll clear the examiner firewall every single time.
All right, beta test time. Let's do a quick code review. If you look at a sample student text block, can you run a trend extraction and spot the logic error in their comparative analysis? I'll give you a second. Often, a student will write an entire paragraph comparing two Arabic texts, but they just list out facts. Text A says this, text B says that. The program compiles, sure, but it scores 0 analytical points. Why? Because it failed the comparative operator standards. Let's check the documentation.
So the crucial point here is that a true high-scoring comparative analysis must perfectly execute this logic table. You can't just list facts. You must identify similarities and differences. You must use comparative connectives, words like whereas, similarly, conversely. Those are your logical operators. You've got to support every single claim with hard evidence, and finally, state a conclusion about their relative importance. If your code block doesn't hit all 5 of these requirements, it's just incomplete.
Section 4. Final code deployment. The code's been audited, the bugs are patched, and it compiles successfully. Let's push this final patch to the main server.
But remember, before we launch, we have to master the highest cognitive domain, evaluation. Deploying true, high-scoring evaluation requires you to actively identify the limitations of the data you just analyzed. What assumptions were made in the text? Are there alternate interpretations? And most importantly, how do these limitations actually affect your final conclusions? Evaluation isn't just summarizing what you wrote, it's stress testing your own code to prove exactly how robust it is.
So here is your final optimized cheat sheet architecture to process the exam methodically and secure maximum marks. Go ahead and screenshot this mental terminal. First, apply the deconstruct, solve, evaluate algorithm to complex problems. Next, follow strict formatting conventions. Those headings and annotations really do matter. Third, deploy the peel patch to guarantee your answers are rooted in context. And finally, ensure deep, evidence-based comparative analysis using your comparative connectives.
You now have the exact source code required to clear the examiner firewall for Paper 4. The key now is applying this framework directly to your specific subject and level. So, are you ready to compile your knowledge and hack the mainframe? Make sure to hit subscribe on Ace the Exams, click the bell, and leave a comment below with your subject and level. Keep practicing, keep stress testing your arguments, and I'll see you in the next Masterclass Explainer. End of line.